Hi everyone. We use database transactions quite frequently in our code, and the purpose of the database transactions is to keep the database or our data state consistent. So what we do, we start a transaction context and execute some code within the transaction context or transaction scope. And what does it mean is, within that transaction scope or that transaction context, any queries that we apply on the database that inserts the data or that updates or deletes or modify any kind of data, they are all those SQL queries are executed in that transaction scope. So if everything goes well and the transaction is committed successfully at the end, all the data is stored permanently into the database, and if anything goes wrong at any point while those methods are being executed within a transaction scope, then the whole transaction is rolled back. So the purpose is, either we save all the data that we want to save, or we do not save any data at all. A simple example is, if we want to take some money from one account and add it to another account. Imagine a situation like we withdraw the money from first account, and while we are adding this money to the second account, we get an error. So should we save the changes to the first account where the money is detected, and while we are unable to add the money to the second account? If this scenario happens, like the money is detected successfully and not added to the second account, that means we are losing someone's money. So in this case, we should have a transaction. If the money is deducted from first account and is added successfully to the second account, only in that case we will commit that transaction. That means everything is fine. The money has been successfully transferred from account A to account B. But if anything goes wrong into this process, money is deducted from first account but not added to the second account, what we will do, we will roll back the whole transaction. So the money which was deducted from the first account is added back. So we stay in the consistent state, like either the data is successfully or the money is successfully moved from account A to B, or no changes happen to any of these accounts. So that is the purpose of the transaction. When we create a transaction context or transaction scope, any code that we execute within that transaction scope is by default executed within that transaction context. So if we start a transaction and we have a method, say add customer, and then we add some orders to the database to different tables, and then we finally add some payment to some other tables, and they could be in different databases as well. Or no, when we talk about WCF, it is possible to flow the transaction from one service to another service as well. So ideally, we are talking about these methods could be anywhere. They could be on different services, WCF services, different modules working on different databases, different servers. They can all be added or executed under the one transaction context. And in this, if they are all executed within one transaction context, what does it mean is, the customer should be added successfully, orders should be added successfully, payment should be added successfully. Only then we will complete the transaction. If we get an error at any state, say while we were adding payment, we got an error, we will roll back the transaction, and all the changes that happened into add customer and add orders will be rolled back as well. Okay, that's fine. Excellent. We want that behavior to make our system stay in the consistent state. But there are some situations where we want some code to avoid this default behavior of the transaction. For example, database in our systems, issue tracking is one of the major thing that we spend a lot of time on that. When there are some errors, if we deploy a system into the live and there are some errors, we go through different logs and through the code and through different databases and tables to see, okay, where did system fail. So we go in a sequence and try to find out, okay, this part was done, this part was done, or the system might have failed at this point because it did not add this to database, or it did put this message into the log and then we did not see any other log messages. So one of the things that we regularly or consistently do while we're writing the code is to put some log messages. We usually categorize log messages into different categories, and based on those log messages, we get some help to track the issues. Okay. Now log messages, there are a variety of ways to put the log messages. We can put log messages to the Windows event log, to our own event log file, into a text file or notepad file, or we can store these databases we can store these log messages to a database table or to an XML file as well. Now imagine we have a standard component to add logs, and what does it do? It takes the log messages and persists it into a table. Okay, so in this kind of scenario that we discussed here, like start a transaction. Now imagine we have this component which stores the log messages to the database. It is used in add customer, add order, and add payment as well. Now if everything is good, the log component, because the code of the log component is also executed within the same transaction. If everything goes fine, transaction is successful, the log messages will be persisted to the database as well. But what if there is some exception? What will happen to those log messages? So let's see this example. I have some code here, and in this code what I'm doing is it's just a small sample application, and I am using two tables. So let's have a look. There are two tables. One is the person table where we store the customer information, and then another is the log table where we have a logger component which store the log messages. So we can see there all these tables are empty at the moment, and this table is where we store the customer information, and this is the log messages. So we, as part of log message, we store application name, which is logging the message, event type, it is error, information or warning, then message details and what time the event occurred. Okay, and now when we go to the code, so I have a method called add payment. What does it do? It starts a transaction scope, and within the transaction scopes I am adding a customer first. So I say customer dal dot add customer, and I create a new customer, Daud Ashraf, and his email, and then some other details. I pass these details to the customer dal, so that customer, if it doesn't exist, it can be added. And then I have commented this method add payment. We will uncomment it later, and then I commit the transaction, complete the transaction. And when we go to this add customer, this add customer is using a standard log component, and for log info, it can log some information like new customer is added, or in case of an error it can again log error. And this is this standard component. It's just a small, so it has an interface called ilog, and it has one attribute property which is location, like where to store the log messages, and then this add method. Okay, at the moment there is only one implementation to this interface ilog, and that is log writer. So this log writer class implements this ilog, and what it does, it simply stores this information, the log message information, to the database. So using entity framework, it creates the entity framework context, and then it adds the log messages to the log table and then save changes. Okay, the location that we provide, it uses that location. So we provide the connection string to the log table, and then this component will open a connection to that database and store these log messages. So this log component is used here. Okay, so let's see. So I have pressed the add button and we should have yes, so we have one customer added, and also there is a message new customer Daud added to the database and at this time. Okay, so now let's clear these tables, and then what we do, I go to the starting point. Okay. Okay, in starting point, just to explain a little bit more to you, so it's just a simple form. I am initializing a customer del in the constructor of this form class. Then a connection string is set, like which connection string the del should use to store the customer details, and then the customer del need a logger component, which I just showed you. So I initialize a log writer class, and log writer class needs a location, and in location I'm passing the connection string to the log table. Okay, and then this transaction scope is created. Okay, now we have executed this code, so it has successfully added a customer detail and a log message to the database, and transaction was committed. That means everything went fine. Now I uncomment this code where I say first add the customer, then add the payment and complete the transaction. So in this case, if both of these operations are successful, like the customer is added successfully and then the payment is added successfully, only then we will get the transaction complete. If anything failed, say the customer is added but the payment failed, we will come back to this exception clause. This complete method of the transaction won't be called, and when we'll go to the exception, because we have this transaction scope in the using statement, so dispose method will be called and transaction will be rolled back as a result of the dispose, and we will not get anything into the database. So let's execute this code. Okay, so here we go to the constructor and we initialize our stuff in the constructor, and we come to the add method. Transaction scope is initialized, and add customer. So if we go inside the add customer, we have this method. So add customer, it again initializes the entity framework context, and then it add that customer detail to the context, and then call the save changes. This save changes mean that the changes should go to the database, and then it add this log message as well, like log info new customer, and with the customer name is added. So as part of this line, one log message should go to the log table. Okay, this code executed successfully, and now we are going to add the payment. Okay, inside the payment, when the method starts, there is one log message that I added. It's logging information, like system is going to add a payment to this to an account. Okay, and there is some exception. So okay, so let's see. We should not be having an exception on adding log information. So what's error? Violation of the primary key constraint pk log. Okay, so there is something wrong in the database table. So let's see what is our table. So log events, and inside log events we have a table called log. We go to its design and what? Okay, id is primary key, which is big int. So what's wrong with it? Okay, yes, so it should be an identity key, auto increment key, which I forgot to add. Okay, so let's execute the code now. In fact, let's redo the entity model again. We delete it, and then we re-add. Okay, so this table is added. okay, and fine. Okay, now let's try. Okay, let's clear the database first if there is anything. 11, so customer is added here, and then okay, so log message is added, and we come back, we call the second method, which is add payment, and log information. So information is added, but here I'm explicitly throwing an exception to fail this second method. So let's throw this exception, and in exception clause we add another log message, which is the log error, and then this exception is rethrown to the method where transaction scope for is working. So now we have come to this exception clause in here, and this transaction scope is not committed. This statement is not executed. That means transaction has been aborted. No. Okay, so if in this kind of scenario the transaction is aborted, should we get something in the log table or not? Okay, we have nothing saved. That's fine. The transaction functionality is brilliant. Transaction is not committed, so we do not get anything at all into the database. No changes were persisted partially to the database. Either the changes should have been persisted successfully, or they should all fail. So everything failed, that's fine. But what we missed, we put the log messages to see where the system has failed, to get some information, so that in case of we need to track some issues in production, we can go through these log messages and see, oh, the customer was added, and then the system was trying to add a payment, and then we got an error like the payment failed. So we will exactly know, oh, system failed to execute the code which was trying to add a payment to the table, and then we can go to that place and find out what could be the cause of the error. But with this behavior of the transaction, we do not get anything in the log. So that is because the default behavior of the transaction, that any code that runs under that transaction context or the scope, by default enlists itself as part of the main transaction. So what we need to do here is we need to set some way, like our code where we save the log messages should not enlist itself as part of the parent transaction. So one of the method to do this is we go to the connection string that was specified. So over here, view codes, over here we are creating our log component, and in location we are passing the connection string. So we say this is a data source, initial catalog, integrate security. So what we can set here is, so we can say, come on, so I can say enlist equal false. So that means any code which is using this connection string to connect to the database will instruct the database, don't enlist this connection as part of the transaction which is already going on. So this will say enlist false. Okay, now we have instructed that our log code should not be executed under the main transaction scope, and let's see what happens. So we go to the customer, add customer, and okay, let's clear what we have in the database. Okay, we do not add anything. So we go to add customer, we save changes, then we added one log message which is the information, and then we say add payment. We went to the end, add payment, log information, then an exception, then with an exception we log the error, and then we rethrow this exception. This exception comes here, transaction is not completed, that means rolled back. Okay, and we get the error here, and what is in the database. So we say select from these tables. Yes, we did not save anything into the customer table, but now you can see we have saved our log messages. And if we have these log messages, we say new customer added, system is going to add payment, then error adding payment. Okay, so and we can see the method or operation is not implemented. So if we get these log messages, then once there is an error, we simply open our log file or log database, and then we go through these log messages and we exactly know where the error is. So issue tracking will be much easier with these kind of log messages. But if we are saving these log messages into the database, we need to be careful, like this code of saving log message to the database does not enlist itself to the main threads transaction or the parent transaction scope. If we do not change this default behavior, we will lose all the log messages as well if the transaction is aborted. So one way to change this default behavior of not enlisting your special code that you want to avoid is to put enlist equal false into the connection string, and then that part of the code will exclude itself from the parent transaction. And in these kind of scenarios, it is really mandatory to not list this kind of code into the parent transaction. Okay, see you soon.